New Deep Dive.
Welcome to the Deep Dive. Today we're looking at semiconductors. I mean, these tiny, tiny components, they're basically invisible workhorses, right?
Absolutely. Powering everything. Your phone, AI, complex medical tech, they're fundamental.
Exactly. And that makes the whole industry critical globally. So our focus today is the UK. The UK is really making this ambitious push, a strategic effort to solidify its position in that global semiconductor landscape.
It's a fascinating move given the global competition.
Yeah, and we've pulled together, a whole stack of recent stuff, articles, government announcements, research insights.
Lots to dig into.
The idea is to give you, our listener, a really rapid but comprehensive understanding of what the UK is doing, the strategy, the investments, these new facilities popping up.
Kind of a shortcut to getting up to speed.
Right, a shortcut, yeah, with some hopefully surprising facts and key insights along the way.
Okay.
So let's unpack this first part. The UK isn't just, dipping its toes in. It seems like they've got a proper long-term plan.
That's the impression. The National Semiconductor Strategy, right. Unveiled back in May 2023.
And it's comprehensive, like a 20-year vision.
20 years, that's significant commitment in tech terms.
And there's money attached. Up to £1 billion in government investment over the next decade. Now, how does that stack up globally? Is that a lot in this space?
Well, it's a significant number for the UK, definitely, and you have to see it in context. Semiconductors are, like we said, strategic, national importance.
Right.
So countries everywhere are making huge plays. Think the US GTS Act, the EU equivalent. So $1 billion is the UK planting its flag, aiming for resilience for specific growth areas. It's necessary to even be in the game at this level.
Got it. And building on that, just recently,
Yeah.
May 2024, they announced the British Semiconductor Institute.
Exactly. This is key. It's designed as an independent body. The goal is to sort of knit together the different players.
Like government universities.
Government universities and, critically, the private sector.
Yeah.
It's meant to be a coordinated entry point.
Ah, so if a tech firm wants to collaborate.
Right. Or an international partner. They have one place to go. And it's also about making sure the researchers, the people actually doing the innovation, that they have the tools, the infrastructure they need to, turn great research into actual products.
Makes sense. And there was something else complimentary about Horizon Europe.
Yes, that's important too. The UK's gaining access to the CHIPS joint undertaking. That's part of Horizon Europe.
Which is the big EU research program.
Exactly. That's about $1.3 billion there for joint projects. Plus, the UK government is adding another, $35 million, specifically to boost UK participation in those joint projects.
So it's strategy, coordination, funding, and international links.
It's trying to build that whole ecosystem, yes.
Okay, so beyond the big strategy of the Institute, we're seeing actual specific cash injections too, right? New facilities.
We are. There's the new UK Semiconductor Centre you mentioned. That's got up to $19 million backing it.
And its role is?
Again, strengthening the UK's position, driving innovation. It's a focused investment.
And there was another one. Something about AI.
Yeah, a smaller pot, £7 million, but specifically targeted at AI-driven semiconductor research.
Yeah.
Which is obviously a huge growth area.
So these targeted investments, what's the strategic thinking there? Why not just put it all into one big pot?
Well, targeting lets you focus on specific strengths or critical gaps. You build essential infrastructure in one area, maybe foster a particular type of R&D where the UK thinks it can really lead.
I see, like building foundations.
Exactly. Building those specific capabilities that can then benefit the wider industry. It's about creating these pockets of excellence.
Okay, let's zoom in then.
Yeah.
Some of the actual physical places where this is happening, these aren't just standard labs, are they?
No, some are pretty unique. Take the Advanced Electron Lithography Laboratory. That's at the University of Southampton.
Right, I read about this. It's the first e-beam lithography lab of its kind in Europe.
First in Europe, and apparently only the second one, globally outside Japan. That's quite exclusive.
And the tech itself sounds incredible. A 200 kiloV JEOL system, processing sub-5 nanometer structures.
On 200 millimeter wafers.
Sub-5 nanometers. I mean, that's hard to even picture. Creating elements thousands of times smaller than a human hair.
It is mind-boggling precision.
What's the real significance of being able to do that? Why is that specific capability so important?
Well, it's about enabling the next generation of chips. That level of precision, sub 5 nanometers, unlocks performance and efficiency gains that are critical for things like advanced AI, sophisticated medical devices, next-gen defense systems.
Oh, okay.
Because only a few places can do this, it gives the UK a real edge in R&D for these future applications. It's not just keeping up, it's potentially leading in certain niches. It unblocks a strategic bottleneck in design and prototyping.
And this lab is housed within a pretty large clean zone, too.
Yeah, an
Yeah.
820 square meter specifically designed clean zone at the Mountbatten complex there in Southampton. You need that extreme cleanliness for this kind of work.
Right. But, okay, making these incredibly tiny things is one challenge. Getting them ready for the real world, that's another step, isn't it? Packaging.
Absolutely crucial and often overlooked. It's a known bottleneck.
And there's a new facility tackling that in Scotland.
That's right, the Semiconductor Power Packaging Scale-Up Line. It's at the National Manufacturing Institute, Scotland, NMIS.
Okay.
It's a 9 million town facility due to launch in 2025, based at the University of Strathclyde's Advanced Net Zero Innovation Center.
And this one is also a first in Europe.
First of its kind in Europe, yes,
Right.
focusing specifically on power semiconductor packaging scale-up.
You said packaging is vital, a bottleneck. Why exactly? It sounds simple, just putting a chip in a case.
Oh, it's much more complex than that. Packaging does protect the chip, yes, but it also provides the electrical connections, heat dissipation, and the physical interface to the outside world. Especially for power semiconductors, which handle high voltages or currents, the packaging is critical for performance and reliability. And doing it efficiently, at scale, that's a major manufacturing challenge. There's a real capacity gap there.
So this NMIS facility aims to fix that.
Precisely. The big impact they're highlighting is cutting the packaging time for UK firms from potentially months down to just days.
Wow, months to days. That's huge.
It directly addresses that capacity gap, and it's housed in a 600 square meter facility.
And I saw something about repatriation, bringing part of the supply chain back.
Yes, that's a key strategic goal. They estimate this could help bring back a $500 million segment of the UK's electrification supply chain.
Electrification, so like electric vehicles, renewable energy systems.
Exactly. Areas where power semiconductors are vital. So it's about boosting domestic capability, reducing reliance on overseas packaging houses, which improves supply chain security.
And it helps companies test things out too.
Yeah, that's another benefit. Companies can use the facility to explore new packaging technologies, run tests, optimize processes without having to stop their own production lines. That lowers the risk of innovation.
And it's collaborating with another group, CSA Catapult.
Right. Collaboration with the Compound Semiconductor Applications Catapult. They work to help commercialize compound semiconductor tech, so it's a good fit. Pooling expertise.
Okay, so we have the strategy, the institute, the funding, these amazing high-tech labs for design and now packaging. But you need people, right? Skilled people.
Absolutely fundamental.
Yeah.
You can build the best labs in the world, but without the talent, they won't deliver.
And the UK is addressing that. I remember seeing something about a support package.
Yes, the Semiconductor Competence Support Package,
Oh.
about $4.75 million.
Okay. Not huge compared to the billion, but targeted.
Very targeted. It's explicitly aimed at the talent gap, which everyone agrees is a major barrier to growth in this industry, not just in the UK, but globally.
So what does that funding actually do?
It funds things like scholarships for electrical engineering students,
Yeah.
specific courses in IC design, that's integrated circuit design, basically chip blueprints,
Right.
and also educational programs in schools, trying to build that pipeline right from an early stage, get kids interested.
So it's a long-term investment in human capital.
Exactly. You have to develop the workforce alongside the technology. You can't have one without the other if you want sustained leadership. It's arguably just as critical as the machines themselves.
Makes sense. So with all this investment, this focus, what's the economic picture looking like? Is it already making a difference?
Well, the baseline is already pretty significant. Semiconductors are estimated to contribute around $10 billion a year to the UK economy already.
10 billion, okay.
And the forecast, driven partly by these initiatives and market growth, is for that to potentially grow to $17 billion by 2030.
17 billion, that's a substantial jump.
It is. And if you look just at that packaging piece we discussed, that specific market segment in the UK currently employs about 15,000 people. It's valued at around 500 million now, projected to hit 750 million by 2030.
So real jobs, real economic value, and significant growth projected.
Yes. These figures really frame the UK's ambition. It's about economic resilience, positioning themselves in a high-growth, globally critical market, tapping into that potential.
But it's not all completely smooth sailing, is it? There was some recent, let's say, nuance about that initial 1 billion pound commitment.
Ah, yes. The political context. With the change in government in 2024, there's been some uncertainty raised about whether that full £1 billion over 10 years, initially announced under the strategy, will be delivered exactly as planned.
Right. The report suggests the new Labour government might be shifting the emphasis a bit, more towards attracting private investment.
That seems to be the narrative emerging, focusing more on leveraging private capital alongside public funds.
So what does that mean potentially? What are the risks or maybe opportunities if there's more reliance on private money for something that's foundational?
Well, it raises interesting questions. Private investment is, of course, absolutely vital. It brings market discipline, agility, it can accelerate commercialization, scale things up faster, perhaps.
Okay.
But large-scale public funding, especially early on, plays a crucial role, too. It often de-risks the initial, very expensive stages, the fundamental research, the big infrastructure builds like those labs. Consistent public commitment signals stability and attracts that private investment.
So it's a balance.
It's a delicate balance. The potential shift could mean some projects relying more on finding private backers sooner, which might affect timelines or the types of projects that get funded, or it could successfully unlock even more total investment if the conditions are right.
Yeah. So it's something to watch, how that public-private funding dynamic plays out.
Definitely. It's an evolving situation, and how that balance is struck will be really key to the long-term success of the whole strategy.
Okay. So quite a journey we've been on there. We've unpacked this multifaceted UK approach to semiconductors. You've got the big national strategy, the coordinating institute,
The targeted funding injections.
those really groundbreaking labs like the E-beam facility in Southampton, the packaging center in Scotland.
And the crucial focus on talent development, too.
Right. So hopefully you, the listener, now have a pretty comprehensive picture of what's happening in this key sector. It touches so much of modern tech and the wider economy.
It really does underpin so much. Which leads to a final thought, perhaps.
Go for it.
Well, we live in an era where everyone's talking about supply chain security, resilience, especially after the recent chip shortages.
Laughing.
So the question maybe to ponder is, how critical is it really for a nation like the UK to not just be good at the innovation, the R&D part, but to also significantly boost its domestic manufacturing capabilities for these foundational technologies like semiconductors? Is innovation enough, or is making the actual things just as vital now?
That's a great question to leave things on. Innovation versus manufacturing, or maybe the need for both. Lots to think about there.